The growing focus on the development of intelligent network systems and the use of big data analytics will assist traffic management and result in reduced congestion and roadblocks. The adoption of advanced sensors and GPS signal systems is revolutionizing the urban traffic network. These systems are designed to help reduce network congestion and act as alerts that notify traffic authorities of potential roadblocks and how to avoid them. The sensors are installed in trucks, ships, and airplanes that give real time insights into drivers' capabilities and the traffic. GPS signals are utilized for bottlenecks and predict the condition of the transportation network. Followed by that, we have the emergence of smart vehicles. The advent of smart vehicles will help reduce the network congestion across several cities in the world. These are connected vehicles that provide real time estimation of traffic patterns that help authorities with the deployment of management strategies. These systems are designed to improve the communication, vehicle to infrastructure communications, and monitor the traffic control to reduce collisions and accidents. Additionally, the implementation of speed trackers, traffic sensors, and display boards will result in smarter roads and help control speed and traffic issues effectively. Followed by that, we have telematics solutions. Telematics is extensively used in traffic management to provide statistics and information data such as weather condition, traffic conditions, and navigation systems. These systems provide real time information, and authorities leverage predictive analysis to determine the state of transportation network. Moreover, telematics provide speech based internet access to the consumers through wireless links that monitor the driver's state and stress levels and send alerts to the systems if there is any issue to avoid or reduce chances of collision. Now, we shall discuss the outcomes and solutions offered. Big data analytics assessments on traffic network congestion identifies a set of transportation indicators that are measured using the mobile phone data available to travel agencies to optimize route planning. Some of the solutions offered are developed an integrated platform to perform data analysis in a scheduled, easy, and controlled way using a user friendly interface, offered an exhaustive understanding of how traffic demand is distributed in the transportation network and how it varies over time, and listed the different types of bottlenecks of the transportation network and enabled enhanced route planning, evaluated the travel delay due to congestion based on travel time distribution between peaks and non peak periods, provided a comprehensive analysis of total number of trips made to and from each zone based on day, time, month, and holiday. Next, we shall learn the architecture of intelligent traffic management systems. ITS generally has cameras set up on most populated areas of metropolitan cities. These cameras collect the visuals data in the form of photos and videos. This data is collected and stored in a storage unit. Generally, HBase is used for the job as it is capable of storing all sorts of data regardless of the type of data. Now, there are n number of calculations and processing that is applied onto the collected data. So, for an offline data processing procedure, we use MapReduce, whereas on the other hand, we use some high end processing frameworks for online and interactive applications. The procedure involves active data mining for fetching most accurate data. The data is ingested into RDBMS and other servers using Scoop, where the data is aggregated and the legacy applications are run over the data to analyze the data and provide the traffic department with latest updates in the live traffic. Now, our next concern would be learning the approach to intelligent traffic systems. There are five different stages in which the intelligent traffic control system works. They are traffic data collection, traffic data transmission, traffic safety measures, traffic data analysis, and lastly, providing the traveler with latest traffic updates as per his needs. Let's discuss each one of them. The first one, Traffic Management Center. Traffic Management Center is the vital unit of ITS. It is mainly a technical system administered by the Transportation Authority. Here, all data is collected and analyzed for further operations and control management of the traffic in real time or information about local transport vehicles. Well organized and proficient operations of Traffic Management Center depend on automated data collection with precise location information, that analysis of data to generate accurate information, and then transmitting it back to travelers. Let's understand the entire process in a more detailed way. The first stage is data collection. Strategic planning needs precise, extensive, and prompt data collection with real time observation. So, the data here is collected via varied hardware devices that lay the base of further ITS processes. This data is collected and stored into a storage unit. Generally, HBase is used for the job as it is capable of storing all sorts of data regardless of the type of data. Now, there are n number of calculations and processes that need to be applied onto the collected data. The next stage is data transmission. Rapid and real time information communication is the key to proficiency in ITS implementation. So, the aspect of ITS consists of the transmission of collected data from the field to TMC and then sending back the analyzed information from TMC to the travelers. Traffic related announcements are communicated to the travelers through the internet, SMS, or onboard units of vehicles. Other methods of communications are dedicated short range communications or DSRC using radio and continuous air interface, long and medium range, that is CAILM, using cellular connectivity and infrared links. Followed by this, we have the safety. Intelligent transport systems' top priority is to make sure the travelers are safe. It mainly targets on the making way for emergency vehicles like fire and safety, ambulance, and curbs. It looks after real time traffic information, analyzes it, and redirects the emergency vehicles to the most favorable routes to reach their destination faster and safer. The next stage is data analysis. The data that has been collected and received at TMC is processed for further in various steps. These steps are error rectification, data cleansing, data synthesis, and adaptive logical analysis. The inconsistencies in data are identified with specialized software and rectified. After that, the data is further altered and pooled for analysis. This mended collective data is analyzed further to predict traffic scenarios which are available to deliver appropriate information to users. Lastly, the traveler information. Travel Advisory Systems or TAS is used to inform transportation updates to the traveler. The system delivers real time information like travel time, travel speed, delays, accidents on roads, change in route, diversions, work zone conditions, etc. This information is delivered by a wide range of electronic devices like variable message signs, highway advisory radios, internet, SMS, and automated cell call. With urbanization expanding with speedy stride, the number of vehicles on road is also increasing. Combination of both in return puts enormous pressure on cities to maintain a better traffic system so that the city keeps on moving without any hassle. For the purpose, application of intelligent transport system is the only solution. ITS is a win-win situation for both citizens and city administrators where it provides safety and comfort to citizens and easy maintenance and surveillance to city administrators. Now, moving ahead, we shall understand the hardware requirements of ITS. The hardware requirements for ITS are categorized into three major components. Those are the field equipment, communication systems, and traffic management center. Now, these three components have further requirements which are mentioned below. They are field equipment, that is the inductive loop detectors, magnetic detectors, infrared and microwave detectors, acoustic detectors, and video imaging. Moving ahead, the next one is the communication system, which requires wired and wireless communications. Followed by that, the last one is the traffic management center, which requires basic facility of staff, signal control unit, traffic surveillance, freeway control, integration for regional control, incident detection, incident response team, information dissemination, electronic tolls, rail crossing monitors. Now that we have a brief idea about the hardware requirements of ITS, let's move ahead and understand the major challenges faced by ITS. So, the major challenges faced by ITS are lack of resources for operation and maintenance of ITS technology, lack of in house technical capacity to process, understand, and analyze the data, lack of advanced analytic solutions in the public transport industry, lack of knowledge on ITS systems and capabilities to specify suitable terms when contracting ITS services to vendors. Followed by that, the lack of knowledge among vendors on specific needs of public transport operations, which significantly affects the utility of the end product. Now, with this, we shall now move ahead and wind up our session discussing the benefits of ITS. Data is stored in data centers in different regions with global access. Each data center is universal live backup. It offers real-time statistical data analysis. It has common data source, which is shared among offline analysis and interactive applications. It offers full text search capabilities inside the storage systems. It has an inbuilt indexing system to offer synchronization of traffic data. Standard Edge-based interface increases image storing and processing performance. It integrates our language support for Edge-based, HDFS, and MapReduce. Finally, exponential reduction in designing logic for complex data mining.
So who's a big data engineer? Now, every data-driven business needs to have a framework in place for the data science and data analytics pipeline. And a data engineer is the one who's responsible for building and maintaining this framework. Now, these engineers must ensure that there is an uninterrupted flow of data between servers and applications. So in simple words, a data engineer builds, tests, maintains data structures and architectures for data ingestion, processing and deployment of large-scale data-intensive applications. Now, data engineers work in tandem with data architects, data analysts, and data scientists. So they must all share these insights to other stakeholders in the company through data visualization and storytelling. But what does a big data engineer do exactly? Now, the most crucial part of a big data engineer is to design, develop, construct, install, test, and maintain the complete data management and processing systems. They are basically the ones who handle the complete end-to-end infrastructure for data management and processing. They build a pipeline for data collection and storage and funnel the data to data analysts and scientists. So basically what they do is they create the framework to make data consumable for data scientists and analysts so they can use the data to derive insights from it. Note that the data engineers are the builders of data systems and not those who mine for insights. So the data engineer works more behind the scenes and must be comfortable with other members of the team producing business solutions from this data. Now all their responsibilities revolve around this. They need to take care of a lot of things while performing these activities. Hence, one of the most sought after skills in data engineering is the ability to design and build data warehouses. This is where all the raw data is collected, stored, and retrieved from. Without data warehouses, all the tasks that a data scientist does will become obsolete. It is either going to get too expensive or very, very large to scale. Now, data engineers should always keep in mind that the system which he or she builds needs to be scalable, robust, and fault tolerant, so that the system can be scaled up without increasing the number of data sources and can handle a huge amount of heterogeneous data without any failure. Now imagine a situation wherein the source of data is doubled or tripled, but the system cannot scale up. Will it not cost a lot more time and resources to build the same system again, which is suitable for this kind of intake? Exactly. This is why the big data engineers have a role here. Next, he or she is the one that handles the extract, transform, and load process, which is basically the blueprint for how the collected raw data is processed and transformed into data ready for analysis. Now you're going to acquire a lot of data from different sources. How do you bring them together to one platform? ETL is your answer. Apart from all this, a data engineer should always aim at deriving insights by acquiring data from new sources. Some of the responsibilities of a data engineer also include improving data foundational procedures, integrating new data management technologies, and the software into existing systems and building data collection pipelines. And finally, one of the major roles of a data engineer is to include performance tuning and make the whole system way more efficient, which is pretty self-explanatory if you ask me. Now, most of us have some idea about who a big data engineer is, but there's still some confusion about their responsibilities. Now, this ambiguity further increases when we gain more information about the role. Now let me help you debunk all your queries about it. So let's talk about some big data engineer responsibilities. First up, we have data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. Now, a data engineer would need to know how to efficiently extract the data from a source, including multiple approaches for both batch and real-time extraction, as well as needing to know about the incremental data loading, fitting within small source windows, and parallelization of data loading as well. Now, another small subtask of data ingestion is data synchronization. But because it's such a big issue in the big data world, we are going to talk about it. Now, since Hadoop and other big data platforms don't support incremental loading of data, a data engineer would need to know how to deal with detecting changes in the data source, merge and sync changed data from sources into the big data environment. Next, we have data transformation. This is basically the T in the extract, transform, and load that we had discussed earlier. It is basically focused on integration and transformation of data for a specific use case. Now, a major skill set here is the knowledge of SQL. As it turns out, not much has changed in terms of the type of data transformations that people are doing now compared to purely relational environments. Now, imagine all this data that you've acquired from various sources. What would you have to do to make them all palatable in the same platform? You need to transform that data, and this is what a data engineer does here. And finally, we have performance optimization, which is one of the tougher areas because anyone can build a slow performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall systems are a higher level of data engineering skill. Now, for example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and creation of reports, the data engineer needs to know how to denormalize, partition, and index data models. He also needs to understand tools and concepts regarding in-memory models and OLAP cubes. Now let's quickly move ahead and look at the required skills to fulfill these responsibilities. Now we'll be going through these skills in a clockwise order, so starting with big data frameworks. Now with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing this framework, it not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which cater differently for different purposes and professionals. For a big data engineer, mastering big data tools is a must. Some of the tools which you will need to master, first of all, you have HDFS, which is the storage part of Hadoop. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with Hadoop framework. Next, we have Yarn, which performs resource management by allocating resources to different applications and scheduling jobs. Now, MapReduce is a parallel processing paradigm which allows data to be processed parallelly on top of the HDFS. Next, we have Pig and Hive. Now, Hive is a data warehousing tool on top of HDFS which caters to professionals from an SQL background to perform analytics on top of HDFS, whereas Apache Pig is a high-level platform which is used for data transformation on top of Hadoop. Now, Hive is generally used by data analysts for creating reports, whereas Pig is used by researchers for programming. Both are pretty easy to learn if you're already familiar with SQL. Next, we have Flume and Scoop. Flume is a tool which is used to import unstructured data to HDFS, and Scoop is used to import and export structured data from RDBMS. Now next we have Zookeeper, which acts as a coordinator among the distributed services running in a Hadoop environment. It basically helps to configure management and synchronize services. And finally, we have Oozie, which is basically a scheduler which binds multiple logical jobs together and helps in accomplishing a complete task. Next up, we have real-time processing frameworks. Now, real-time processing with quick actions is the need of hour. Either it is a credit card fraud detection system or a recommendation system. Now, imagine if you wanted a red dress today and Amazon decides to suggest it to you a month later. Now, wouldn't that be completely useless for you? In this case, you need real-time processing. It is very important for a data engineer to have knowledge of real-time processing frameworks Now, Apache Spark is one of the distributed real-time processing frameworks which is used in the industry rigorously. It can be easily integrated with Hadoop leveraging HDFS as well. Next, we have DBMS. Now, a database management system stores, organizes, and manages a large amount of information within a single software application. Now, data engineers need to understand the database management system to manage data efficiently and allow users to perform multiple tasks with ease. This will help data engineers in improved data sharing, data security, data access, and better data integration with minimized data inconsistencies. These are the fundamentals that data engineers should know prior to building a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry, such as Oracle DB, Microsoft SQL Server, etc. Now, data engineers must have at least the knowledge of one such database. Now, knowing SQL is also a must. This structured query language, as SQL is also known as, is used to structure, manipulate, and manage data stored in relational databases. As data engineers work closely with our DBMSs, they need to have a strong command on SQL. Now next, we have NoSQL technologies. As the requirements of organizations have grown beyond structured data, NoSQL databases have been introduced into this environment. It can store large volumes of structured, semi-structured, or unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are HBase, Cassandra, and MongoDB. Now, HBase is a column-oriented NoSQL database on top of HDFS, which is great for scalable and distributed big data stores. It is also great for applications with optimized read and range-based scan, and it provides consistency and partitioning out of CAP. Now, Cassandra is a highly scalable database with incremental scalability, and the best part about Cassandra is the minimal administration and no single point of failure. It's good for applications with fast and random read and writes. It provides available and partitioning out of CAP. And finally, we have MongoDB, which is basically a document-oriented NoSQL database, which is a schema-free database. It gives full index support for high performance and replication for fault tolerance. It has a master-slave sort of architecture and provides CP out of CAP. It is rigorously used by web applications and semi-structured data handling. Next, we are going to discuss programming and scripting languages. So various programming languages can serve for the same purpose. So knowledge of one programming language is enough. I'm saying this because the flavor of language may change, but the logic remains the same. If you're a beginner, you can go ahead with Python as it is an easy language to learn due to its syntax and good community support. Whereas R has a steep learning curve, which is developed by statisticians, and it is mostly used by analysts and data scientists. The next skill we're going to discuss is an important one. It is ETL or data warehousing. Now, data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply extract, transform, and load. Now, data warehousing is used for analytics and reporting and is a very, very crucial part of every business intelligence solution because this is the part which is going to take you most time. Now, it is very important for a big data engineer to master one data warehousing or ETL tool. After mastering one, it becomes pretty easy to learn new tools and as the fundamentals remain the same. Now, Informatica, ClickView, and Talend are very well-known tools used in the industry. Informatica and Talend Open Studio are data integration tools with ETL architecture. The major benefit of Talend is its support from the big data frameworks. If you're new to data warehousing and ETL tools, I would definitely recommend you start with Talend because after learning this, any data warehousing tools will become a piece of cake. And finally, we have our operating systems. Now, intimate knowledge of Unix, Linux, and Solaris is very helpful as many mathematical tools are going to be based off of these systems due to their unique demands for root access to hardware and operating system functionality above and beyond that of Microsoft's Windows or Mac OS. Now, some level of understanding of how to act upon this data is also very valuable for data engineers. For this reason, some knowledge of statistical analysis And the basics of data modeling are also hugely valuable. Knowledge of machine learning in cloud also will serve as a big plus. While machine learning is technically something relegated to a data scientist, knowledge in this area is helpful to construct solutions usable by your cohorts. Now, this knowledge has the added benefit of making you extremely marketable in this space, as being able to put on both hats, in which case makes you a really formidable tool.
Now, let us quickly start with our first chapter. The first chapter is about learning why exactly we need to test the big data. Most of the users might end up with one question that asks why exactly we need to test the big data. You might have written the queries correct and your architecture might be just fine. Yet, there might be many possibilities for a failure. Let us assume a classic case of a drastic failure that occurred in a bank. The designers of the bank database wanted to create a phone application which could enable phone banking to the customers. So, the designers of the bank database named the customer name as CN, the customer bank location pin code as CL, customer ID as CID, and customer phone number as CP. Now, the bank wants to make key value pairs of customer ID, which is CI, and customer phone number, that is CP. In this scenario, the MapReduce algorithm gets messed up between the letters P and L, which is a keypad error or the typing error. Now, the customers won't be getting the OTP and the phone banking facilities. Just imagine this scenario in a real-time situation. Horrible, right? So to avoid such mistakes in real time, we prefer the big data testing. Now we shall understand what exactly is big data testing. So big data testing can be defined as a procedure that involves examining and validating the functionality of big data applications. The big data is a collection of a huge amount of data that traditional storage systems cannot handle. Testing such a huge amount of data would take some special tools, techniques, and terminologies which will be discussed in the later section of this tutorial. Followed by this, we shall understand the strategies behind testing the big data. Testing an application that handles terabytes of data would take the skill from a whole new level and out-of-the-box thinking. The core and the important test that a quality assurance team concentrates is based on three scenarios, namely batch data processing test, real-time data processing test, and lastly, the interactive data processing test. So what exactly is batch data processing test? The batch data processing test involves test procedures that run the data when the applications are in batch processing mode, where the application is processed using batch processing storage units such as HDFS. The batch data processing test involves test procedures that run the data when the application is in batch processing mode. In this, the application is processed using batch processing storage units such as HDFS. The batch processing test mainly involves running the application against faulty inputs, varying the volume of the data. Now, next comes is the real-time processing test. The real-time data processing test deals with the data when the application is in real-time data processing mode. The application is run using the real-time processing tools such as Spark. Real-time test involves application to be tested in the real-time environment and it is checked for stability. And the last one is interactive data processing test. The interactive data processing test integrates the real-time test protocols that interact with application as in a view of the real-life user. The interactive data processing mode uses interactive processing tools such as Hive SQL. Now moving ahead, we shall understand the different forms of big data. So there are three main forms of big data, which are structured format, semi-structured format, and unstructured format. Firstly, we shall understand what is the meaning of structured data. Any tabular data which is meaningfully organized under rows and columns with easy accessibility is known as structured data. It can be organized under named columns using different storage units such as an RDBMS. For example, any tabular data stored in an RDBMS. Now, we shall understand what is semi-structured data. Semi-structured data lies perfectly between structured and unstructured data. It cannot be directly ingested into an RDBMS as it includes metadata, tags, and sometimes duplicate values. Data needs some operations to be applied on it before the data is ready to be ingested. For example, .csv format and .json format. Now lastly, we shall understand what exactly is unstructured data. Data that does not obey any kind of structure is known as unstructured data. Unlike the structured data, the unstructured data is difficult to store and retrieve. Most of the data generated by organizations is unstructured type of data. For example, image files, video files, and audio files. Now we shall understand the big data formats in a little detailed way, where we have the examples for structured, semi-structured, and unstructured. Firstly, we shall deal with the structured data. So the structured data is available from the sources like data warehouses, databases, ERP, and CRM. Now when we enter into semi-structured data, we find the sources from .csv files, .xml files, .json files. And finally, we come into the unstructured data, and the sources for the unstructured data are audio files, video files, and image files. Now we shall move ahead and understand the big data testing environment. Owning a perfect environment for testing big data applications is very crucial. The basic requirements for big data testing are as follows. Firstly, space for storing, processing, and validating terabytes of data should be available. Then, the cluster and its respective nodes should be responsive. And lastly, the data processing resources such as a powerful CPU should be available. Now with this, let us enter the big data testing. So the general approach in big data testing involves three stages. Firstly, the data ingestion stage. In the data ingestion stage, the data is first loaded from the source to the big data system using extracting tools. The storage might be HDFS, MongoDB, or any other similar storage. Then the loaded data is cross-checked for errors and missing values. The basic example for data ingesting tools is Talend. Followed by the data ingestion phase, we have data processing phase. In this stage, the key value pairs for the data get generated. Later, the map reduce logic is applied onto the nodes and checked if the algorithm works fine or not. A data validation process takes place where we make sure that the output generated is as expected. And finally, the last stage is about the validation of the output. At this stage, the output generated is ready to be migrated from the data warehouse. Here, the transformation logic is checked, the data integrity is verified, and the key value pairs at the location where the data needs to be dumped is validated for accuracy. So these are the three phases in which the big data is tested. So with this, let us into the next chapter where we will deal with the different categories in which a big data application can be tested. Firstly, unit testing. Unit testing in big data is completely similar to any other unit testing in similar applications. The complete big data application is divided into segments, and each segment is rigorously tested with multiple possibilities for an expected outcome. If any segment fails, then that particular segment is sent back to the development stage for improvements. Now, after unit testing, we enter functional testing. Functional testing can be otherwise called as different phases in testing the big data application. The big data application is designated to deal with huge blocks of data. Such a huge volume and variety of data is often prone to bring data issues such as bad data, duplicate values, metadata, missing values, and whatnot. This is exactly why the pioneers in testing the big data designed the procedure for functional testing of big data. The different phases in which the big data is tested are as follows. Firstly, the validation phase. Data validation phase deals with the business logic and the layers of big data application. The data is collected from the source and it is run against the business use case. Data collected is checked for accuracy and movement through the different layers of the application. At this stage, the big data is tested with aggregation and filtering mechanisms. The data undergoes end-to-end validation and transformation logic based on business rules. The next stage is data integrity phase. Data is checked for completeness with referential integrity validation. Data constraints and duplication is verified against error conditions. Boundary testing recognizes schema limits for each layer in integrity phase. The next phase is data ingestion phase. This is a very important phase where the data gets ingested into the Hadoop ecosystem. The ability of the application to connect with different data modules is checked here. The data is replayed with messaging systems and loss of data is monitored. The main motto of this phase is to achieve the following qualities. Firstly, fault tolerance, then continuous data availability, and lastly, stable connection with a variety of data streams. Followed by data ingestion phase, we have data processing phase. The data processing phase carefully examines and executes the business logic. The business rules are cross-validated. The MapReduce logic is validated at every stage. Data is processed from end to end. The application is checked for exceptions and they get perfectly handled. Followed by the data processing phase, we have the data storage phase. The data storage phase concentrates on the following parameters, which are the read and write timeouts, continuous data availability, load balancing, and finally the query performance analysis. After all these stages, we have one final stage, which is called the report generation phase. It is the final stage in functional testing and it deals with the following: data validation for measures and dimensions, real-time reporting, data drill up and data drill down mechanisms, and lastly, the business reports and chats. So this was the functional testing. Now let's move ahead and understand non-functional testing. The non-functional testing phase takes care about three major dimensions and characteristics of big data, which are the volume, velocity, and variety of big data. There are 5 stages involved in non-functional testing, which are data quality monitoring, infrastructure, data security, data performance, and failover testing mechanism. Firstly, we shall understand data quality monitoring. Data quality monitoring checks for erroneous data, records, and messages. Data quality monitoring makes sure that the following parameters about the data are available, which are the data accuracy, data precision, data timeliness, data consistency, data profiling. Now, the next stage is the infrastructure. The infrastructure makes sure that there is a continuous service availability in both external big data processing applications and internal big data processing applications. Infrastructure also takes care about the data replication factor, data backup, and data restore point. Followed by the infrastructure, we have the data security. Data security is called to be the most important aspect of the big data application. Data security stage protects the sensitive data. It manages user authentication and checks user role-based authorization. Data security also takes care about the data encryption and masking of personal information. Followed by data security, we have data performance. Data performance evaluates every single component. It evaluates maximum data processing speed, evaluates maximum data capacity size, checks the message transfer speed and response time, calculates the number of operations performed per unit time, engages parallel job monitoring, and finally performs read, write, and update operations on real-time databases. And lastly, we have failover test mechanism. Failover test mechanism ensures seamless data processing while switching to neighboring data nodes. It creates data recovery points and parallelly, it will be ready for any unexpected calamities. Failover test mechanism will be ready to replay the data using multiple offsets. It enables dynamic clustering. With this, let us move ahead into the next type of testing, which is based on the performance testing. Performance testing highly concentrates on the performance delivered by all the components in the big data system. Performance testing includes the following categories. Firstly, the data collection phase, data ingestion phase, data processing phase, and finally, component testing phase. Firstly, we shall understand what is data collecting phase. In this stage, the big data system is validated based on its speed and capacity to grasp the data within the given frame of time. Data can be collected from different sources such as RDBMS, databases, data warehouses, and many more. The next stage deals with the data ingestion. Here, the application is tested and validated based on its space and capacity to load the collected data from the source to the destination, which might be HDFS, MongoDB, Cassandra, or many other similar storage units. Followed by the second stage, the third stage is data processing stage. Here, the application is tested based on the MapReduce logic written. The logic is run against every single node in the cluster and the processing speeds are validated. The queries to be executed are expected to perform with high speeds and low data latency. And finally, we have the component testing. This stage is related to the component performance. Each component in the system should be highly available and connected. The component backup should be online when any node fails. High capacity data exchange should be smoothly supported. Now with this, let us move ahead and understand the performance testing approach. The performance testing approach can be understood through the following flow diagram. Firstly, the procedure begins by establishing a big data cluster and running the application. Later, the big data developer designs the workload required to run the test. Then in the next stage, we involve the clients into the test and take their feedback. After that, execute the application with data and analyze the results. And now, if we find the application to be performing with optimum stability, then the process is finished. Else, we applied the required modification and retest the application. So this is the performance testing approach. Now, followed by this, we shall understand the parameters involved in performance testing. So the parameters involved in performance testing are data storage. Data storage takes note of the orientation in which the data gets stored in the system. Followed by that, we have commit logs, which marks the limits for committing logs. Followed by that, we have the concurrency, which checks the number of threads allocated for the read and write process. And next to the concurrency, we have caching. Caching includes dedicated row cache and key cache. And finally, we have timeouts. The timeouts set the timeouts for the application, which are related to the connection and queries, etc. Followed by the performance testing, we have architecture testing. Architecture testing concentrates on establishing a stable Hadoop architecture. The Hadoop architecture of big data processing application plays a key role in achieving smooth operations. Poorly designed architecture leads to chaos, which might be performance degradation, node failure, high data latency, and may require high maintenance. So these were the chaos which may show up if you have a poor architecture in your big data application. Followed by this, we shall understand the big data testing tools. So the big data testing tools are majorly classified into four categories. Firstly, big data ingestion tools, then big data processing tools. Followed by that, we have the big data storage tools, and lastly, we have big data migration tools. Now we shall look at the examples based on each one of them. Firstly, the big data ingestion tools. Zookeeper, Kafka, and Scoop are the best examples for data ingestion. Next, we have data processing, and the popular tools used in big data processing are MapR, Hive, and Apache Pig. The next kind of tools are the data storage tools. The most famous examples for data storage are Amazon S3 and HDFS. Finally, we have the data migration tools, and the popular examples for data migration are Talon and CloveDX. Now with this, we shall move ahead and understand the challenges faced in big data testing. So the key challenges faced in big data testing are: big data testing is highly complicated and the process requires highly skilled official. Automated big data testing procedures are predefined and they are not suited for unexpected errors. Virtual machine latency creates latency in tests and managing multimedia is a big hassle. Followed by that, the volume of the data is one major challenge for big data testing. The testing environment and automation should be developed for different platforms. Each component is from a different technology, hence it requires isolated testing. No single tool can perform end-to-end testing. Followed by that, high degree of scripting is required for designing test cases. And finally, customized solutions are required to increase performance and test in critical areas. So with this, we shall move ahead into the last topic, which deals with the difference between traditional testing and big data testing. So the first difference is the big data testing supports all type of data testing, whereas the traditional testing supports only structured testing. The next difference between the both is big data testing requires research and development, whereas in traditional data testing, we don't require research and development. The third difference is the data size is unlimited in big data testing, whereas the data size is limited in traditional testing. Followed by the third difference, we shall enter the fourth difference, which says big data testing requires special environment, but whereas the traditional testing doesn't require any kind of special environment. So now we shall enter into the last difference, which says only highly skilled and qualified candidates can perform big data testing, but when it comes to traditional testing, the basic operations knowledge is enough to run the tests.
Let's take a look at the various application domains that big data offers to the industries. As big data is growing at an exponential rate, various fields in day-to-day life are using big data to ease the process of storing and processing the data. So here I have listed few of the sectors that have been implementing big data like healthcare, education, e-commerce, government, IoT, and even in media and entertainment. Now, let's look at each of these domains in depth. First, let's see how big data is used in healthcare industries. Guys, you all know that there is a huge amount of data generated in healthcare industries, and that data includes patient records, transactions, research data, and many more. So, traditionally, what happened? They failed to use the big data. Why? Because they had the limited ability to store and consolidate the data. Okay, I got a query from Piyush. He asks how big data analytics has improved healthcare industries. Thank you, Piyush, for this question. I'll explain you how. Big data analytics have improved the healthcare by providing personalized medicine and prescriptive analytics. Not only that, but also the researchers are mining the data to see what kind of treatments are more effective for particular conditions, and based on that, they identify the patterns that are related to drug side effects and then provide the solution that can help the patients and reduce the cost. And also on adoption of mHealth, eHealth, and wearable technologies, the volume of data is increasing. And that includes electronic health records data, CRM data, that is customer relationship management data, fitness trackers, historic patient, research data, purchase data, and many more. So now let me tell you why demographic data plays a vital role in healthcare industries. Here, what we do is we map the healthcare data sets with the geographical data sets. And by doing that, it's possible to predict the disease that will escalate in specific areas. And based on these kind of predictions, it is very easy to strategize the diagnostics and then plan for stocking serums and vaccines. So this is how big data analytics has enhanced the healthcare industries. Now let's see how big data is used in real world clinical analytics. Healthcare industries wanted to replace their legacy data warehousing solution with a data lake that could manage high volumes of data. In order for this, healthcare industries selected a company called CTS Tech, which is a specialist provider for healthcare, to build the solution. So CTS Tech designed the solution based on Cloudera Hadoop distribution, MapReduce, Spark streaming, and other Hadoop technologies. So here is how it works. Here we have diagnostic results and billing messages. This is nothing but the data source from where we get the data. And this data is injected into the data ingestion stream, wherein it undergoes Spark streaming and produce real-time data streams. And these real-time data streams are capable of processing 20,000 records per second. And they are then landed onto the Cloudera landing zone, wherein it undergoes deduplicating, cleansing, and standardization of the data. And once deduplicating, cleansing, and standardization of the data is done, it is then processed using MapReduce job and data processing stream. And this processed data is queried using Cloudera Impala. Now we populate and store the messages from Cloudera Impala into IBM Unified Data Model for healthcare organization. And from there we visualize the results and dashboard, and then we arrive at the solution. So this is how CTS Tech has used big data analytics and provided the solution in real-world clinical analytics. Now let's see how big data is used in education sector. Big data is revolutionizing the way we manage education sector. So how is it doing that? Here I have jotted down few of them. First, let me tell you how it is used in improving evaluation of student results. Guys, can you guess what is the only way to assess the performance of a student? The only measurement of the performance of a student is the answers that they write to assignments and exams, correct? So, however, during his or her life, each student generates a unique data trail. And analyzing this data trail in real time, one can understand the individual behavior of students, and that helps to create an optimal learning environment for the students. And also, it is possible to monitor student actions, such as how long they take to answer a question, which sources they use for exam preparation, which questions do they skip, and many more. So, by considering all these factors, one can improve the evaluation of student results. Next, analyzing and creating the custom programs. You all know that we have lakhs of students from each and every universities, but customized programs for each and every individual student can be created. Everyone wondering how? That is possible with the help of a technique that is called as blended learning. Confused? What is this blended learning? It is very simple. It is just a combination of online and offline learning. And that gives the students the opportunity to follow the classes that they are interested in. And also, they have the possibility for offline guidance by professors. Next, how big data helps us to reduce the dropout rates. As we have already discussed that it would help to improve the evaluation of student results, it's an obvious fact that the dropout rates at schools and colleges would also reduce. So what does educational institutions do? They use predictive analytics on all the data that is collected to give them insights on future student outcomes. And such kind of predictions will also help to run a scenario analysis on a course or a program before it is introduced into the curriculum. And this minimizes the need for trial and error. Next, now let's see how to compute the marks of students. Let me take an example here. Say, let me take attendees' names itself. Consider Priyat scores 90 marks in mathematics and 60 in geography, but Chaitra scores more in geography and less in mathematics. So what does big data analytics do? It helps to combine and analyze all the data of students, and based on that, importance can be given to each of the students who lack this course and also to give an insight about how to improve the performance. So these are the various ways where we use big data analytics in education sector. Now let's see a case study of IBM in education. It is used to monitor individual student performance, to prevent attrition from a course or a program. Next, to identify outlines for early intervention, to identify and develop effective instructional techniques, for testing and evaluation of curriculum. Now let's see how IBM has used big data analytics in learning analytics flow model. Here we capture instructional transactions as they occur. And these instructional transactions occur in a time-sensitive learning application. And this would be actually possible within a learning management or a course management system. And we use full capabilities of a learning management system and then generate a 15-week online course. And this 15-week online course would generate thousands of transactions per second. And then we perform real-time analysis on these transactions, and that would be used to feed a learning analytics app. And to process all these data, we need a big database system. Without the help of analytic software, it is not possible to process the data in big database system. So we use Apache Spark for data processing, and then we analyze the transactions and establish a pattern, and then we arrive at decisions and course of action. And these decisions and course of action is then introduced into a curriculum or a course management system. So this is how IBM has made use of big data analytics in learning analytics flow model. Now let's see how big data is used in e-commerce industries. Big data is a game changer when it comes to retail and e-commerce. Retailers and e-commerce brands are using more of analytics to drive strategic action and offer better customer experience. So these are few of the usages. First, it is used to predict the trends. In order to predict the trends, we used a trend forecasting algorithm. And this trend forecasting algorithm combines the data from social media posts and web browsing habits to identify what is causing a buzz. And also to know which product is discussed more of online, we perform sentiment analysis task. And based on sentiment analysis and trend forecasting algorithm, it is very easy to predict the trends in the market. Next, optimize pricing. Big data enables retailers to identify best price for goods by tracking transactions, competitor, and cost of goods. And not only that, but retailers can also map the rise and fall of demand and match the pricing accordingly. Now, let's see how analytics has enhanced Amazon to forecast its demand. Analytics enables Amazon to predict the traffic on the website along with the possible conversion rate. And through the Amazon Web Services Cloud, the business has the flexibility to scale up in a real time. So as it can scale up in a real time, analytics enables Amazon to forecast its demand. Next, how one can create a personalized store. We have something called as fast web server technologies. And this fast web server technologies in combination with big data, businesses can generate dynamic websites that are filled with relevant products based on the historic behavior of a consumer and their personal preferences. So, by grouping the personal preferences and the historic behavior of a consumer, one can create a personalized stores. Next, customer service. Customer service is available 24/7 in all the e-commerce industries. So, big data analytics allows business to optimize this customer service. And how does it do? It compiles the data from previous online and offline transactions, social media information, purchase history, and many more. And by this, businesses can create a 360-degree view of the customer, and based on that, they provide enhanced customer experience. Next, sales generation. The main motto of all the e-commerce industries is to sell their goods and products. And retailers use big data to offer a personalized experience and prevent potential abandonment. So by this, we can have more number of sales generated. So these are few of the usages in e-commerce industries. Let's see a real-time use case in e-commerce. Here we have a user. User communicates with the e-commerce server portal in data stream. Here the data is collected from various sources, and that includes customer information, purchase history, reviews, and many more. And we have something called as input selection module to remove the noise from the data. So this input selection module is based on two factors. One, singular value decomposition. Second, dimensionality reduction. So what is the singular value decomposition? It is nothing but the technology that is used to speed up the recommendations with very fast online performance, and that requires just few simple arithmetic operations. So the data which is used to speed up the online performance is selected. Next, what is dimensionality reduction? Here we reduce a number of random variables under consideration that are not required in the data. So based on these two factors, the input selection module removes the noise from the data. So this noise-free data is fed as an input to HDFS input in Hadoop stream. And that input undergoes MapReduce job and produces HDFS output. The data that we get after applying MapReduce job is ready for analyzing. So in the data analytics stream, we use our tool to analyze the data, and from there we arrive at textual and graphical reports, and they are nothing but the reports that are used in prediction of trends, forecasting demand, and in sales generation. Now let's see how government sector has made use of big data analytics. In government use cases, the same data sets are often applied across multiple applications, and that requires multiple departments to work in collaboration. Okay, I got a query from Kalgi. She asks why big data analytics is needed in cybersecurity and intelligence. Kalgi, I'll surely tell you, but for now, let's see how it is used in traffic optimization. Big data helps to aggregate the real-time traffic data generated from road sensors, GPS device, and video cameras. The potential traffic problems in dense areas can be prevented by adjusting public transportation routes in real time. Kalgi, now I will tell you why it is used in cybersecurity and intelligence. You all know that the cyber attacks are increasing in volume and complexity, and that's becoming a tedious task for traditional analytics tools. But companies have to protect themselves against all kind of attacks, and they also need to be able to detect and respond fast. So it's nothing but a PDR paradigm, that is prevent, detect, and respond. And in order to prevent, detect, and respond at a faster rate and quickly, there comes the big data analytics approach. And these challenges can be prevented and overcome with the help of big data analytics. For example, you can say it is used in enterprises to fight against cyber threats. I hope you got an idea about it, Kalgi. Now let's see how it is used in crime prediction and prevention. Police departments use advanced and real-time analytics to understand the criminal behavior, identify crime, and uncover location-based threats. Next, weather forecasting. The National Oceanic and Atmospheric Administration gathers every minute of every data from land, sea, and space-based sensors. And on a daily basis, National Oceanic and Atmospheric Administration uses big data to analyze and extract value from over 20 terabytes of data. Next, drug evaluation. The National Institution of Health uses big data technologies to access large amounts of data to evaluate drugs and treatment. Next, tax compliance. Big data applications can be used by tax organizations to analyze both unstructured and structured data from a variety of sources in order to identify suspicious behavior and multiple identities. This actually helps in tax fraud identification. So these are the various sectors where big data is used in government. Now, let's see how it is useful in e-government portal. So what is this e-government portal? It is an application that uses electronic communication devices, computer, and the internet to provide public services to citizens and the other people. So citizen or enterprise user use certain services via e-government portal. So these user requests are sent to big data infrastructure in order to be processed. And this big data infrastructure has a database that is not centralized, and hence it integrates with database of different ministries, government agencies, and local authorities. So both the databases are then deployed to cloud infrastructure. And in this solution, we use cloud infrastructure to reduce the cost for storage. And here we have Hadoop framework to process the data. We run Pig and Hive queries on a Hadoop data platform and then store this data into HDFS, and then the response is sent back. So now let me tell you the workflow. User sends a request to the network using an appropriate interface. In this case, the appropriate interface is nothing but the web application that he interacts with. And the request is then forwarded to big data, and the processing happens using these technologies, and hence the response is sent back. So this is the internal working that happens, but for the user, when he communicates or interacts with the web application, he gets a response immediately. So this is how big data analytics is used in e-government portal. Now let's see how big data is used in IoT. Data extracted from Internet of Things devices provides a mapping of device interconnectivity. Such mappings have been used by various companies and governments to increase the efficiency. And IoT is also increasingly adopted as a means for gathering sensory data. And this sensory data is used in Medicare, industry, retail, vehicles, communication, and many more. So IoT represents the connected devices. But as there is an enormous amount of data, these devices are connected through IoT, and big data technologies is used to store and process this huge amount of data. Let's take a look at the smart city concept. The combination of IoT and big data is an unexplored research area that has brought new and interesting challenges for achieving the goals of future smart cities. You might have heard of Amsterdam, right? It is the pioneer in the concept of smart city. Now, you might be wondering how it has introduced the concept of smart city. Amsterdam has introduced the concept of smart city in smart government, smart health, smart retail, smart agriculture, and many more. I got one more query here, and this query is from Gino. He asks how Amsterdam has implemented the concept of smart city in smart home. Gino, I will explain you now. In case of smart city, they use a wearable technology. That is, any person in the home can wear the fitness band, that is a wearable technology. And the techies have programmed and integrated this smart thing in such a way that when the person wakes up, the lights will automatically turn on and the coffee machine starts to brew the coffee. And it is vice versa. When the person who is wearing the fitness band goes back to sleep, the light turns off. I hope you got an idea about it, Gino. Now let's move further. In this case, various smart applications exchange information using embedded sensor devices and other devices that are integrated with cloud computing infrastructure to generate large amounts of unstructured data. And these large amounts of unstructured data are collected and stored in a cloud or a data center using a distributed fault-tolerant database, that is NoSQL, and that is used to improve the single service or application and is shared among various devices. And we also have a programming model for processing large data sets with the parallel distributed algorithm, and that can be used for data analytics to obtain the value from the data. Here we have query engine like Hive and Mahout to query and structure the data. So this is how cloud and big data both are used in the smart city concept. Last but not the least, let's see how big data is helpful in media and entertainment. Various companies in the media and entertainment industries like publishers, broadcasters, cable companies, YouTubers are facing new business models for the way they create, market, and distribute their content. And that is happening because of the current consumer search and the requirement of accessing this content anywhere, anytime, and on any device. And big data provides actionable points of information about millions of individuals. And all these insights are gathered through various data mining activities. And big data applications benefits media and entertainment industry by media scheduling, ad targeting, content monetization, audience interest, customer churn prevention. So now let me tell you how to prevent a customer churn. Customer churn is a serious menace that media companies find almost impossible to tackle, and it has been found that at least 30% of the customers share their views through social media. And until big data arrived, combining and making sense of this user data was next to impossible. And with the advent of big data analytics, it is possible to know why customers subscribe and unsubscribe and what kind of programs they like, dislike with crystal clear clarity. So by analyzing all these factors, it is very easy to prevent the customer churn. Let's take a look at the Netflix example in big data. Netflix has tons of user data present in its database system. And this data is processed and analyzed, and we recognize the patterns for that. And here we have a new user request. And this user comes and search for a video in the Netflix search engine. And based on the video preferences and the user choice, we rank the video and also we give user experience. And then we continue to watch the trending video and we arrive at video similarity algorithm. So now let's see how the decision is made and the video ranking is being given. This is decision making Netflix data framework. Netflix uses Cassandra because it is highly scalable and strong on performance. Here we have Cassandra, that is a NoSQL database, and it is used by Netflix because it is very strong on performance. And we have Priam, that is a Cassandra helper tool, and also it is a Netflix cluster management tool that simplifies the Netflix administration, and it also uses API to query the Cassandra metrics. And next we have S3SS tables. The query data is stored in S3SS table in a table format. And we have Aegis, that is a platform built by Netflix engineer to work on Hadoop MapReduce. And this Aegis converts the Cassandra S3SS tables into queryable format. And we have S3JSON, that is a JavaScript object notation, and that is used to structure the query data. And hence, based on all these factors, the decision is made and the video ranking is being given. So if you go back, you continue to watch the trending video and you get the video similarity algorithm. So this is how Netflix has used big data analytics. Now let's move further and see the scope of big data that will create a havoc in the near future. First, 6x growth. It's obvious fact the amount of data that will be generated in the next 5 years will be 6x times more than that what was generated in the past 5 years. So imagine we'll be having huge amount of data. And not only that, but also the Hadoop adoption is growing at 29 times more than that of US GDP. Next, an open source supernova. Let me bring out the comparison here. In 1998, only 10% of the companies used to use open source networks, and that gradually increased to 50% in 2011. And now 78% of the companies use open source softwares, and in the next years, entire 100% of the companies use open source softwares. And these advancements is because of the growth of big data in the market. Next, why it is termed as meteoric innovation. You all know that in 2008 there were more things connected to the internet than people. And now IoT devices represent over 6.48 billion devices connected. And in 2020, the IoT market will connect to over 21 billion devices. And by 2030, self-driving cars will rule the roads of the world. And that is why it is termed as a meteoric innovation. The next, 3x increase in profit. Based on the above three terms, that is 6x growth, open source softwares, meteoric innovation, it is an obvious fact that as the technologies evolve, the growth will be evolved. And that leads to 3x increase in profit rate as well. So in the next few years, the profit rate will tend to increase to 3x times more than that what it is there in today's world. So this is why we say that big data is going to create a havoc in the near future.
Why do you think big data analytics is so important, and why do you feel that we need to study this topic or we should know what exactly it is? So now let me tell you why. So just like the entire universe in our galaxy said to have formed due to the Big Bang explosion, similarly data has also been growing exponentially, which is leading to the explosion of data. So this can simply be termed as big data. And do you know that we are creating about 2.5 quintillion bytes of data every day? And 1 quintillion amounts to around 10 raised to the power of 18 bytes. So you can do the math and imagine the amount of data that we are creating every day. And this data, as you can see from the image that I've depicted here, is coming in from various sources, whether it is from social media, from banking sectors, from governments, from various other institutions, all right? And this data is not in the same format. So it is coming from various sources, so it is in different formats. So now, guys, what do you think? That is big data only limited to the volume or the enormous amount that is being generated? Or does it define with various other characteristics that, exactly define what big data is? So I have put down four such reasons here to tell you that why it is so important and how it is helping many organizations all around the globe. So the first reason here that I've stated is for making smarter and more efficient organizations. So big data analytics is basically highly contributing to these factors, and organizations are adopting this to basically lead them to faster decision making. So one such example that I, came across that I wanted to share with you guys is about the New York Police Department, in short, which is the NYPD. So big data and analytics are helping the NYPD and the other large police departments to anticipate and identify the criminal activity before it occurs. So what they do is that they analyze the entire big data technology to geolocate and then analyze the historical patterns. And they map these historical patterns with sporting events, paydays, rainfalls, traffic flows, and federal holidays. So essentially what the NYPD is doing that they're utilizing these data patterns, scientific analytics, technological tools to do their job. And they're ensuring that by using these different tools, they're doing their job to the best of their ability. So by using a big data and analytics strategy, the NYPD was able to identify something called crime hotspots. So basically where crime occurrence was more. So they were able to identify these hotspots, and then from there they deployed their local officers so that they could reach there on time before it was actually committed. So this is how NYPD basically utilizes entire, this field of big data analytics so that they can prevent crime and make New York a more safer place. So now, after exploring the first reason, let's move on to the second reason and see what is it. So the second reason here is to optimize business operations by analyzing customer behavior. So the best example for this is Amazon. We all know how much Amazon is popular and how much we use it on our daily basis. So Amazon basically uses our clickstream data, that is the customers. So they use our clickstream data and the historical purchase data of more than 300 million customers which have, signed up for Amazon, and then they analyze each user's data, how they're clicking on different products and how they're navigating through their site. So basically they show each user customized results on customized web pages. So after analyzing all these clicks of every visitor on their website, they're able to better understand their site navigation behavior, the paths that people are taking to buying their products and services, and what else a customer looked on while buying that product, and also the paths that led a customer to leave their page. So this information basically helps Amazon to improve their customer experience and hence expand their customer base. So guys, let's see what the third reason is now. So big data technologies like Hadoop and cloud-based analytics, they basically reduce your cost significantly for storage of big data, because for storing big data, if you buy like huge servers and huge machinery, so that is going to cost you a lot. So by using Hadoop technology, so what Hadoop does basically, it stores big data in a distributed fashion so that you can process it parallelly. So it reduces your cost a lot. So by using commodity hardware, they are reducing their costs significantly. So which brings us to our third reason. You must have gauged what the third reason is. It is cost reduction. So now let us see how healthcare is using big data analytics to curb their costs. So using new data tools that send automatic alerts when patients are due for immunizations or lab work, more and more physicians could reduce the hospitalizations by practicing better preventive care. So you know what? The patient started using these new sensor devices at home and on the go. So these new sensor devices, they basically, deliver constant streams of data that can be monitored and analyzed in real time. So they help the patients avoid hospitalization by self-managing their conditions. Now, for hospitalized patients, physicians can use predictive analytics to optimize outcomes and then reduce the readmissions. So Parkland Hospital in Dallas, Texas is one such example which has been using analytics and predictive modeling to identify these high risk patients. And then they predict likely outcomes once the patients are sent home. So as a result, Parkland has been able to reduce its 30-day readmissions back to Parkland and all area hospitals for Medicare patients with heart failure by around 31%. So for Parkland, that estimates about a savings of $500,000 annually, and of course, not to mention that the savings which patients are also realizing by avoiding these readmissions. So this is how healthcare is widely using big data analytics to reduce their costs significantly. Now let's move forward to see the last reason for why big data analytics is so essential. So our last reason is next generation products, that how big data analytics is really contributing to generate more such high tech products. So to see how customers needs can be satisfied and how they can use these new generation products for their own benefit. So I have cited three such examples here for you guys. So the first example here is Google self-driving car. I'm very sure that most of you guys must have heard about it. What Google self-driving car basically does it makes millions of calculations on every trip that help the car decide when and where to turn, whether to slow down or speed up, and when to change their lanes. So the same decision a human driver is making behind the wheel, Google self-driving car is also doing that with the help of big data analytics. Another example of a self-driving car is the Toyota Prius, which is fitted with cameras, GPS, as well as powerful computers and sensors to safely drive on the road without the intervention of human beings. So this is how it is, really contributing to making such high-tech products, which in the long run we'd be using probably, and it will make our life more easier. Now, moving on to the second product that I'm going to cite here. So it's a really fascinating product. Let me ask you a question. How many of you all love watching TV shows? And how many of you all prefer spending your weekends doing nothing but Netflix and chill? Let me guess. Almost all of us do. I mean, I love binge watching shows over the weekend. So I know by now you would have guessed what example I'm arriving to. So it is Netflix. So Netflix committed for 2 seasons of its extremely popular show House of Cards without even seeing a single episode of the show, guys. And this project of House of Cards of 2 seasons, it costed Netflix about $100 million. So guys, how do you think that Netflix was able to take such a big risk monetarily? So the answer to this, my friends, is big data analytics. So by analyzing the viewer data, the company was able to determine that the fans of the original House of Cards, which aired in the UK, they were also watching movies that starred Kevin Spacey, who is playing the lead in the show House of Cards, and they were directed by David Fincher, who's also one of the show's executive producers. So basically, Netflix is analyzing everything. So from what show you are watching to when you pause it or to when even you turn it off. So last year, Netflix grew its US subscriber base by around 10%. And then they added nearly 20 million subscribers from all around the globe. So how fascinating is that? I mean, this is brilliant. I am sure that the next time you guys are watching a show on Netflix, you'll be really happy because you already know how the backend is working and how Netflix is recommending you new shows and new movies. So now moving on to the third example that I've cited here. So it's one of the really cool things that I've come across. So this is a smart yoga mat. Now, this has sensors embedded in the mat, which will be able to provide feedback on your postures, score your practice, and even guide you through an at-home practice. So the first time you use your smart mat, it will take you through a series of movements to calibrate your body shape, size, and personal limitations. So this personal profile information of yours is then stored into your smart mat app, and this will help the smart mat detect when you're out of alignment or balance. So over time, it will automatically evolve with updated data as you improve your yoga practice. So now I'm sure that with these, very interesting and exciting examples, you would have got an idea about what exactly big data analytics is doing and how it is improving various organizations in their sales and marketing sector. So now let's move forward and finally, formally define what big data analytics is. So guys, what is big data analytics? Big data analytics examines large and different types of data to uncover hidden patterns, correlations, and other insights. So basically what big data analytics is doing, it is helping large companies to facilitate their growth and development. So this majorly involves applying various data mining algorithms on a given set of data, which will then aid these organizations in making better decisions. So now that you know why we need big data analytics, what is exactly big data analytics? Now let us see and explore what are the different kind of stages which are involved in this procedure of a big data analytics. So these are the different stages involved in this entire procedure. So the first stage is identifying the problem. So what is our problem that we need to solve? This is the most important step, of course, and it is the first step of the process. The second step is to design our data requirements. So of course, after identifying the problem, we need to decide what kind of data is required for analyzing this particular problem. The third step is pre-processing. So in the pre-processing step, basically cleaning of data takes place and you perform some sort of processing. Now, after the processing stage, we come to the fourth stage, which is the analytics stage. So in this stage, you would be basically analyzing the processed data using various methods. After the analytics stage, we'll move to the final stage, which is data visualization. So in visualization of data stage, you will basically visualize the data using tools like Tableau, AngularJS, but the visualization of data will only take place in the end. So these are the basic 5 stages in this entire procedure. Now that you've understood this, let's move forward and understand what are the different types of big data analytics. So there are 4 basic types. One is descriptive analytics, second is predictive analytics, third is prescriptive analytics, and fourth is diagnostic analytics. So let us understand the first type, which is descriptive analytics. So descriptive analytics basically answers your question, what has happened? And how does descriptive analytics answer this question? It uses data aggregation and data mining techniques to provide insight into the past, and then it answers what is happening now based on the incoming data. So basically, descriptive analytics does exactly what the name implies. It describes or it summarizes the raw data and it makes it something which is interpretable by humans. And the past, which I just referred in this context, it basically can be 1 minute ago or even a few years back. So the best example that I could cite here for descriptive analytics is basically the Google Analytics tool. So Google Analytics basically is aiding organizations or different businesses by analyzing their results through Google Analytics tool. So the outcomes that help the businesses understand what actually has happened in the past, and then they validate if a promotional campaign was successful or not based on the basic parameters like page views. So basically, descriptive analytics is therefore an important source to determine what to do next. Another example is what we saw earlier in the new generation product, which is Netflix. So Netflix basically uses descriptive analytics, as I told you guys, to find the correlations among the different movies that a subscriber is watching. And to improve their recommendation engine, they use historic sales and customer data. So this is what descriptive analytics is. Now let's move forward to the second type, which is predictive analytics. So the second type, which is predictive analytics, basically uses statistical models and forecast techniques to understand the future and answer what could happen. So basically, as the word suggests, it predicts. We are able to understand through predictive analytics that what are the different future outcomes. So basically, predictive analytics provides the companies with actionable insights based on the data. So through sensors and other machine generated data, companies can identify when a malfunction is likely to occur. So then the company can preemptively order parts and make repairs to avoid downtime and losses. So an example of this type of analytics is the Southwest Airlines. So Southwest analyzes their sensor data on the planes to identify the potential malfunctions or safety issues. So basically, this allows the airline to address the possible problems and then make repairs without interrupting the flights or putting the passengers in danger. So this is a very great use of predictive analytics to how basically reduce their downtime and losses, and as well as prevent delays and various other factors like accidents. So now let's move forward to the third reason, which is prescriptive analytics. Prescriptive analytics uses optimization and simulation algorithms to advise on the possible outcomes and answer the question, what should we do? So basically, it allows the users to prescribe a number of different possible actions and then guide them towards a solution. So in a nutshell, these analytics are all about providing advice. So prescriptive analytics, they use a combination of techniques and tools such as business rules, algorithms, machine learning, and computational modeling procedures. So then these techniques are applied against input from many different data sets, including historical and transactional data, real-time data feeds, and then big data. So these analytics go beyond descriptive and predictive analytics by recommending one or more possible courses of action. And the best example for this is the Google self-driving car. This example also we have already seen in the new generation product section. So basically, Google self-driving car analyzes the environment and then decides the direction to take based on the data. So it decides whether to slow down or speed up, to change the lanes or not, to take a long cut to avoid traffic or prefer short routes, etc. So in this way, it functions just like a human driver by using data analytics at scale. Now, prescriptive analytics is a little complex type of analytics and it is not yet adopted by all the companies. But when implemented correctly, they can have a large impact on how the businesses make their decisions. So now let's move on to our last type, which is diagnostic analytics. So diagnostic analytics is used to determine why something happened in the past. So it is characterized by techniques like drill down, data discovery, data mining, and correlations. So diagnostic analytics, it takes a deeper look at the data to understand the root cause of the events. It is helpful in determining what kind of factors and events contributed to a particular outcome. So mostly it uses probabilities, likelihoods, and the distribution of data for the analysis. So for example, in a time series data of sales, diagnostic analytics would help you to understand why the sales of a company has decreased or increased for a particular year and so on. So examples for diagnostic analytics could be a social media marketing campaign. So you can use diagnostic analytics to assess the number of posts, mentions, followers, fans, page views, reviews, pins, etc. So and then you can analyze the failure and the success rate of a campaign at a fundamental level. So therefore, there can be thousands of online mentions that can be distilled into a single view to see what worked in your past campaigns and what did not. So now that we have seen all the four types, I hope that you've understood the different examples of all the four types and the difference between them. Now let's move forward and have a look at the tools which are required for big data analytics. So these are some of the tools that I have listed down here. So there are more such tools which are used for big data analytics, but let us explore the ones which I have mentioned over here. So let me name them: Hadoop, Pig, Apache HBase, Apache Spark, Talent, Splunk, Apache Hive, Kafka. So now let me start with the first one, which is Hadoop. So Hadoop is basically a framework that allows you to store big data in a distributed fashion so that you can process it parallelly. Apache Pig is a platform that is majorly used for analyzing large data sets and then represent these data sets as data flows. So basically Pig is used for scripting and the language is Pig Latin. Now coming to Kafka. So Kafka is a messaging system. Now, guys, what is a messaging system? A messaging system is basically something which is responsible for transferring data from one application to another. So the applications can focus on the data and they do not need to worry about how to share it. So this is what Kafka does. Now coming to Apache Hive. Now Apache Hive is a data warehousing tool. So it allows us to perform big data analytics using Hive query language, which is similar to SQL. Coming to Splunk. So Splunk is a log analysis tool. Now what are logs? So logs are generated on computing as well as non-computing devices, and they are stored in a particular location or directory. So they contain details about every single transaction or operation that you guys have made. So next is Talent. Talent is an open source software integration platform which helps you to analyze effortlessly and then turn the data into business insights. So it helps the company in taking real-time decisions and become more data-driven. Next is Apache Spark. So Apache Spark is an in-memory data processing engine that allows us to efficiently execute streaming, machine learning, and SQL workloads. And it requires fast iterative access to data sets. So basically it is used for real-time processing. Now moving to the last one, which is Apache HBase. So Apache HBase is a NoSQL database that allows you to store unstructured and semi-structured data with ease and provides real-time read or write access. So these were the tools that I could list down, and I have also told you about the different functions in brief that they perform. So now let us move forward and explore the different kind of domains which are, using big data analytics. So these are some of the domains that I've listed out for you guys to understand how they're using big data analytics and how widely it is being used in different kinds of domains. So healthcare, we've already discussed previously, has been using big data analytics to, reduce costs, predict epidemics, avoid preventable diseases, and then improve the quality of life in general. So one of the most widespread application of big data in healthcare is electronic health records, which is EHRs. I'm sure that most of you must have heard about it. It basically stores the patient's entire data. Now coming to telecom industry. So telecom industry is one of the most significant contributors to big data. So telecom industry basically analyzes all our call data records in real time, and then they identify fraudulent behavior and acts on them immediately. Now the marketing division of telecom industry, it basically modifies their campaign to better target its customers and then use these insights which are gained by them to develop new products and services. Coming to insurance companies. So insurance companies use big data analytics for risk assessment, fraud detection, marketing, customer insights, customer experience, and much more. Now, governments across the world are also adopting big data analytics. The Indian government, for example, had used big data analytics to get an estimate of the trade in the country. So, the economists used central sales tax invoices for trade between two states to estimate the extent to which the states were trading between each other. Coming to banks and financial firms. Now, banks and financial services firms, they use analytics to differentiate fraudulent interactions from legitimate business transactions. So by applying analytics and machine learning, they're able to define the normal activity of a user or a customer based on their history and then distinguish it from the unusual behavior indicating fraud. So then the analysis systems, they suggest immediate actions such as blocking the irregular transactions, which stop the fraud before it occurs and improves the profitability. Now, moving on to the next domain, which is automobile. So, many automobile companies are utilizing big data analytics, and one example is Rolls-Royce. So, Rolls-Royce embraced big data by fitting hundreds of sensors into its engines and propulsion systems. And these sensors basically record every tiny detail about the operation of these engines and propulsion systems. So, then the changes in the data in real time are reported to the engineers who will then decide the best course of action, such as scheduling a maintenance or dispatching the engineering teams if the problem arises. Now, the next domain is education. So, education is one field where big data analytics is very slowly and gradually being adopted, but it is very important that we utilize big data analytics in this field because so by opting for big data powered technology, as a learning tool instead of the traditional lecture methods, we can enhance the learning of a student as well as it can aid a teacher to basically track the performance in a better manner. Now, coming to the last domain, which is retail. So, retail includes both e commerce and in stores, and they are widely using big data analytics to optimize their business strategies. So, we already saw that with the example of Amazon. So, now that we've explored the various domains, let me show you the use cases that I have taken here to explain you about how big data analytics is widely being used. So I've taken two such use cases here. So the first use case is of Starbucks. So the leading coffee house chain makes use of behavioral analytics by collecting the data on its customers' purchasing habits in order to send personalized ads and coupon offers to the customers' mobile phones. So the company also identifies trends indicating whether the customers are losing interest in their product and then they direct offers specifically to those customers in order to regenerate their interest. So I came across this article by Forbes which reported how Starbucks made use of big data to analyze the preferences of their customers to enhance and personalize their experience. So they analyzed, every member's coffee buying habits along with their preferred drinks to what time of the day they are usually ordering. So even when people visit a new Starbucks location, that store's point of sale system is able to identify the customer through their smartphone, and then the barista gives them their preferred order. So in addition, based on ordering preferences, their app, which is the Starbucks app, will suggest new products that the customers might be interested in trying. So this is how Starbucks is basically optimizing their business strategies and improving and basically increasing their customer base. Now let's move on and see what is the second use case that I want to share with you guys. The second use case is of P&G, Procter and Gamble. So Procter and Gamble uses market basket analysis and price optimization to optimize their products. So market basket analysis analyzes customer buying habits by finding associations between the different items that the customers place in their shopping baskets. So this is what exactly market basket analysis does. So apart from this, market basket analysis may be performed on the retail data of customer transactions at your store. So stores like Target, Walmart, etc., that they use market basket analysis to basically increase their sales and marketing. So you can then use the results to plan marketing and advertise your strategies or even design a new catalog. So for instance, market basket analysis may help you design different store layouts. In one strategy, items that are frequently purchased together can be placed in close proximity to further encourage the combined sales of such items. So example, I'm going to a store, I want to buy bread. Then I also, cite butter. So I will want to buy butter as well. So that's how, stores optimize their sales. So they place all these products like butter, bread, milk, eggs in close proximity because they know when a customer comes to buy bread, they might also want to buy butter or milk or eggs. All right. So this is one such example. So how PNG basically utilizes it is the company uses simulation models and predictive analytics in order to create the best design for its products. So it creates and sorts through thousands of iterations in order to develop the best design, for example, for a disposable diaper. And then they use predictive analytics to determine how moisture affects fragrant molecules in a dish soap so that the right amount of fragrance comes out at the right time during the dishwashing process. I mean, so we can't even imagine that a simple product like a dish soap also has so much thought process behind it and also has so much strategies or, analytics applied behind it. So I hope that you guys found both these, use cases really interesting and how more such companies are utilizing big data analytics in a more proficient manner in order to basically increase their sales and marketing. So now let's move forward and see the next one, which is facts and statistics by Forbes. So I've collected some of these, so four, which I found really interesting and I wanted to share with you guys. So the first one here basically states that nearly 50% of respondents to a recent McKinsey Analytics survey say that analytics and big data have fundamentally changed business practices in their sales and marketing functions. So we also have seen examples of this by, like by Starbucks, of P&G, of Amazon. So these are such companies which are responding to such surveys. Now the next one is showing that how big data applications and analytics is projected to grow from about $5.3 billion in 2018 to $19.4 billion in 2026, which attains about a compound aggregate of 15.49%. So the next one here is an extremely important fact or a stat which I found out, and it is basically an eye opener. So according to an Accenture study, 79% of enterprise executives agree that companies that do not embrace big data will lose their competitive position and could face extinction. Even more, 83% have pursued big data projects to seize a competitive edge. So this very fact, guys, tells you that how important this field is, and if your particular organization or company is not adopting big data analytics in the future, it is going to lead to obsolescence. So now let's see which is the last fact that I have stated here. So according to New Vantage Venture Partners, big data is delivering the most value to enterprises by decreasing their expenses by about 49.2% and creating new avenues for innovation by about 44.3%. An example of both of these facts we saw in New Generation Why We Need Big Data Analytics section, where we spoke about cost reduction as well as new generation products. So this is an example of that. So now let's move forward and look at the career prospects in big data analytics. So the first one here that I've stated here is there is a soaring demand for analytics professional. So technology professionals who are experienced in big data analytics are in high demand as organizations are looking for ways to exploit the power of big data. So therefore, there is a soaring demand for analytics professional, and as and when the data is going to grow, more such people will be required to analyze that data. So that leads us to our second point, which is huge job opportunities. So there are more job opportunities in big data management and analytics than there were last year. And many IT professionals are prepared to invest time and money for the training. So now that companies under various domains are adopting big data analytics, so there are definitely more huge job opportunities. So now let's see what are the salary aspects. So I think this is one of the most important ones again, because we need to know that what kind of salary are we going to draw if you become a big data analytics professional. So six analytics and data science jobs are included in Glassdoor's 50 best jobs in America for the year 2018. These include data scientist, analytics manager, database administrator, data engineer, data analyst, and business intelligence developer. And the average salary of the six analytics jobs that I just stated, along with data science jobs, is about $95,000, which is absolutely amazing. And data scientist has been named the best job in America for about 3 years running, with a median base salary of $110,000 and 4,524 job openings. I mean, how wonderful is that? So you guys can see that how great the prospects are in this field, and if you guys are interested, then you should definitely learn more about this field, and who knows that you might be drawing such kind of a salary. So but in India, the percentage of analytics professionals commanding the salaries lesser than 10 lakhs, it has gone lower, which is great. So the percentage of analytics professionals earning more than 15 lakhs has increased from about 17% in 2016 to 21% in the last year 2017, and to the current 22.3% in this year 2018. Now let me tell you what kind of job titles are there in this field. So the first one here is Big Data Analytics Business Consultant. Second is Big Data Analytics Architect. Third is Big Data Engineer. Fourth is Big Data Solution Architect. Fifth is Big Data Analyst. Sixth is Analytics Associate. Seventh is Business Intelligence and Analytics Consultant. And the last one is Metrics and Analytics Specialist. So I've just stated 8 over here. So these might be addressed in different names and different job titles. And there are more such job titles, I'm sure, so you can explore that. So now let's move on to see what are the skill sets that you require if you want to become an analytics professional. So these are the few skill sets that I've mentioned over here, and there can be more depending on the role that you're going to play, or maybe even restricted to one particular skill set. So it depends upon what role are you going to play in this field of big data analytics. So the first one is that I've put down here is basic programming. So you would obviously be expected to know some kind of a general purpose programming language. The second one here is statistical and quantitative analysis. So it is preferable if you know about the statistics and quantitative analysis. Now moving on to data warehousing. So knowledge of SQL and NoSQL database languages such as MySQL, and NoSQL has MongoDB, Apache HBase,